Okay, so where we were, so last time we were, seems like we have some new people. So last time where we were doing a retail system. And can somebody remind me the requirements?
Online shopping is that kind of a
Online shopping.
Yeah,
Okay.
product catalog.
Catalog, yeah.
Search, payment.
Search, yeah. What else?
Cart.
Cart, then. Anything else you think? There, we discussed a lot of things.
Yeah, invoice, order.
Order,
Inventory.
yeah.
So comparing the products in the same category.
That would be, I will say, a tricky thing. So I will not put that thing right now. So I also want to scope it out. So anything else you think like should be the minimum viable plan to
Inventory.
Inventory management. Shipping. Yes. So it seems like these are like things which are like a minimum MVP for me to get started with my online retail system. So what we discussed last time, like if this is my client and this is one service which is taking care of everything, and this is a backend, and then this is like a monolithic architecture for me. Like one service is handling everything, and we discussed about advantages, disadvantages, and then discussing that having a API gateway, and then it would be connecting to different services. Service 1, service 2, service 3, service 4, they can talk to same DB, and then we started breaking into different DBs as per our need. So these all things right now, all the communications right now happening using REST. That's what I have assumed last time. And initially our system is new. We are having a small number of requests, like 100 requests, but now as my system is going mature and a lot of users are coming to my system, now the requests can go high from 100 to let's say the request can go from 10,000 to 100K. And then we spoke about different components, like how I can scale different components on need. Like these services can scale based on the load, CPU, and other things, and we can manage. But what else you see here could be problematic?
If there are several services that talk to the same database, could that be a bottleneck?
Yeah, that could be a single point of failure. So we can split that based on whenever we need into different data stores. And there could be so many things, but let's say like I have a system which is sending me a lot of, or this system communicate to this system, and so this service communicate to this service, and this service communicate to another service to get data. Like say the user data is here, the catalog data is here, and we have some other data like order data is here. And now what happens is now what happens like on a particular day I'm getting lot of orders, And after that, the order service is calling an external component like a Visa. So it is getting bombarding like 100K requests per minute. So basically it will try to call Visa service like with 100K requests per minute. Do you see any problem here? Like I'm getting a lot of requests, and would my system able to handle? I can scale them, but still the problem could be the backend could be bottleneck. The other services could not able to scale. The Visa service could not able to scale. That is not in my control because Visa is external component. So what should I do? And right now everything is happening synchronously. Like one component to call other component, wait for that, and that component wait, call other component, wait for that, and everything is happening synchronously.
So you want for every request you are sending it to Visa, you are waiting for the response?
I can send it to Visa. Visa can, I can bring Visa down with too many requests. Like if they put some kind of API rate limiter, they can start denying my requests. Or my other components not able to scale, they will start sending me 500. Basically, order would call catalog, catalog will call some other thing. And in this way, this could be really like...
So can I, on that note, can we think about, so we are talking about coupling of microservices here, right? Like order is calling catalog or something. So if we put sort of something like a timeout, right? Or some sort of signal that we can pass on to the order, microservice that tells me kind of to slow down or something like a contention signal. And that way I can adapt my traffic to order.
No, but that means like even I have to tell my users slow down.
Yeah, I mean, we don't want to do that, but I'm thinking like, is there something we can do at the order microservice level that coming to the async point, right? Right now we are trying to address and accommodate every request as it comes. Is there, I don't have a very concrete idea, but I'm just thinking aloud about the traffic pattern, and is there something we can do at the order microservice level to kind of balance out the traffic within it, or I don't know.
So the problem is like overloading with order requests, right? So what we need to do is either one is to put the queue in front of our service, the other one is to throttle the number of requests for each user. So we limit it, and then for the outgoing call, we can make it become like asynchronous. So when we just make the call and we forget it, and we have a callback handler. The other third party, they can either process it or within certain timeout, we can detect it, and we may retry it for a few times. And
so yes, so this is a really good way of thinking. I think that's how we should evolve our thinking in an interview also. How if this some so did everybody got like what Leon was trying to explain, that there could be different ways to find it. One is throttle it, like a API rate limiter. But do I actually want to throttle? The more I'll throttle, the revenue I'll lose. Do I want that or no?
Just a question. Doesn't that lead to a bad user experience? And apart from that, does the Visa call has to be in sync? Given that Visa is a payment call, it has to be in synchronous, right? We cannot do it in an async fashion, right? So I think we also have to take care of that. Isn't like, because it's a payment thing, right? Because payment thing has to be carried out synchronously. Only then our order can get a confirmation saying that, cool, dude, you can proceed further. Yeah. Just understanding the requirements.
But Tanish, on that point, like sometimes when we place an order, we first get an email about order is still processing, right? haven't gotten a confirmation yet that it's processed and confirmed. So from that perspective, I'm thinking that can we think around async? Like when it's in async mode, we haven't gotten a confirmation. So at that time, the user will still get a message that order is under process. And then once that's done, then you give a final confirmation.
Yeah, but yes, good point, DP, but we are directly going to the solution. So
But then I have a question. Like that doesn't happen in a normal e-commerce website, right? In a normal e-commerce website, if you see, like we actually wait for the payment to happen, and then only we can proceed further, right? If you take a normal use case, like if you wear a customer hat and see from their perspectives, because if I make a payment, right, to you guys, and if I'm not sure what is going to happen to my payment, I won't buy another product because I'm not 100% confirmed that whether my payment has been processed or not. If I keep on placing orders and it keeps on failing, like you give me a mass failure, I mean, I am screwed in that way, right? I mean, customer trust is lost in that particular.
Yeah, maybe I can add a little context. So I think your point is right, Tanesh. So what in real systems normally, at least like before confirming the order, at least I think there is a kind of payment authorization without actually settling, because I worked in payment related scenarios previously. So normally there is an authorization like kind of hold, or it's not actually charged in payment perspective, but like just making sure the provided details are valid and can be charged later for this amount. So normally before confirming that order, so that is done. So if your workflow is simply saying order received, then at that point I don't think that is done. But if somebody says order confirmed, then that needs to be done, because otherwise, like with you cannot confirm an order without getting an authorization from the payment, whatever the customer provided. So it depends on the workflow how you design, like whether it's order received or order confirmed, like order shipped. There are like various states, right? Life cycle of an order.
Yes.
So Aseem, what I'm getting from our discussion is that we actually have to, like, what you're saying is, but we have to still do it in a synchronous fashion, right? So for this problem statement, I think we have to scale it, but then we have to scale it such that all the requests are in a synchronous fashion, correct? Like just confirming.
So I have worked in a retail-based system, so I know, like Naga mentioned, there are different stages of the order. We'll not go really deep in that, but there are different stages, like received order, confirmed, shipped, and delivered. So that needs not to be like synchronous. Like if you see like till shipment also, it's all asynchronous. Different components has to work and then say a final decision like, okay, this is done.
Correct.
So
correct.
In this case also, what I'm trying to mention is we can do synchronously. If it is a small system, like if I have only 100 requests coming, I can directly call the Visa, even confirm, like, do I have a inventory or not? So most of the times when you see things on online, they give you a picture like, okay, there could be 10 items in our inventory. But in real time, it will again check the inventory system. Like, do I have that item still or it is gone? Because it depends on how you implement your system. Do you want to make a lock when somebody is putting in the cart, or you want to check again, revalidate when somebody's making order and say, okay, sorry, we don't have inventory right now. That would not be a good customer experience, but it depends on how we are designing our system.
Correct. No, I am saying what you're saying is absolutely correct. Like I think the logistics manifestation and all those things that we do, inventory calculation, that can happen after like order is confirmed. But I'm just talking particularly about the payment piece, right? So once an order is, let's say, in the initiated state, you are saying that order has been confirmed, like, and like I would say order shipped and all those things can be updated in an async fashion. That's fine. Like you can just do it in an async. Even though I think the API calls that you have to make to your logistics providers and everything for the pickup and everything to begin, that can be in an async fashion. But I'm just talking particularly about the payment piece over here.
Okay. So let's come to that. But right now my thing is I have different components which will not be able to scale. when I'm getting my order, like in my inventory service, my other components, which will not be able to scale. So I want a way, if I throttle it, I'm losing my orders. But if I want to take that orders and process them on the pace which I can do, what should I do now?
Yeah, so you can basically have so you can have your different regions, right? If you're using a AWS cluster, you can have services at your different regions, and then you can basically horizontally as well as vertically scale them. And for your DB, you can actually shard it. Don't you think that approach would...
In West Coast, only one region, and right now all my customers are also in this region. I'm only let's say going for California state, and all my users are there. It's not multi-region, it's a single region, and I don't want to scale it so crazy that I should start. So I don't want to scale it really crazy, because the more I'll scale, the more hardware cost I'm paying.
So you can actually use AWS Lambdas, right, or something of that sort. Not just that, you can put a load balancer and you can actually just have different instances. And the best thing about cloud is that you can just call basically. I think there are some instances that you basically get when you actually have the load. Otherwise, AWS automatically kills them. Right, I don't know what those sort of instances are called, but there is a functionality to do that. So we can have those sort of instances. If your load is getting too much, you can actually just spin off a new instance that is going to be added to your load balancer. Just scale your infrastructure, and obviously you would be sharding it. Obviously, you're sharding your database as well. So don't you think that would be better rather than doing it in an async fashion?
So agree with you. Theoretically, everything is possible. Practically, when we start looking for scaling and doing things, it would come up with its own cost, processing times, and there would be a lot of complications. Like I was mentioning, there could be some component which is written old. It could not be like it would be like old service. In a typical, if you see any team system, there could be services which are really old. There could be services which are modern. There could be components which could not be scaled well. We are talking about a perfect scenario where everything is Lambda, everything could be scalable, sharded, database could be sharded. But typically, I think so. I have worked in different projects. I have never seen like a system which is perfectly scalable, scale automatically, and also brings it down and kills extra incidents. There is always cost. So that's why we're always talking about throttling, API rate limiter. Otherwise, we could have serve request as much user is wanted.
Correct.
So Aseem, what's your take here that for the problem you just shared?
Yeah, my take right now is not to solve exactly this problem, but to bring a component which I have used earlier in such scenarios and could be helpful in other patterns where the communication can happen based on the queues. So like I think Leon was mentioning that if I take everything in, so basically if I start my orders in a queue, and then this service will start picking up that orders, and it does not have to scale in the way the number of requests is coming. It has to only process the requests, the frequency or magnitude it can handle, and after that there could be other system. Once this is done, it will put confirmation in another queue, and that will send it back to the sender that okay, your order is in the processing state or whatever. Initial will only just, as soon as the request will come, will tell like okay, your request is received, put it in the queue. Other services will work on them, and finally once they are done, they will put that in another queue, the confirmation, and some other system will pick that and send it back to the client. Okay, this thing is done. So I was trying to discuss more in that way, and where all we can use this pattern. Even somebody has used in their current project, they can chime in.
Okay.
So, so there are different things when things go in the queue. Let's chat about that. So basically, there is one component which was receiving this requests and putting in the queue. And then there could be some services which could be reading that. Typically, there. So let's say this is order service 1, order service 2, order service 3. This we are not telling like there will be only one order service instance. There could be multiple instances of that. So typically, when I talk about queue, what properties come to your mind?
The size, like of in general, first in, first out, all that, like the type of data structure.
So basically, in typically, I have worked with this Amazon SQS. It comes with 2 flavors. One is this FIFO, and second one is standard delivery. Does anybody has worked on this and share their thoughts? Amazon SQS simple queue service.
Yes, I've worked on it, and as you mentioned, like SQS is used for having a data for a longer period of time. We can actually have the data for a longer period of time, and depends like first in, first out, or as you mentioned, the other model. I've not used the other model. I've only used that, the first in, first out.
Okay, so basically, what I know, like first in, first out is one as so the things which you add first, it's like a standard queue. It follows the property of the queue. What things comes first will go out first. Other is like a standard one where there's no guarantee what order it will come out, and this is cheaper than the first one. That's what I know while working with that. So these are the 2 properties which SQS gives, and I think similarly all cloud providers would have something similar.
Do these
Just
queues?
a question, does
Go ahead.
sorry, Martin, go ahead. Sorry, you go ahead.
Mm-hmm.
Does SQS also maintain, like gives you a guarantee that you will receive a message, or if you have not received a message, like it only delivers once, or it guarantees that once unless you have not sent an acknowledgement back to the queue, it will hold the message for you?
So basically, you mean like one? So you mean after the
Like
message
at least once guarantee like that? I think he is speaking, right? At least once delivery. Is that,
Yeah, so what I'm asking is that, like, let's say first time you have sent me a message, but due to some reason my service failed, right? So would SQS, like, do a SQS guarantee that it will hold the message unless I have processed it and give it an acknowledgement back, or it just delivers once and it's like out of the queue? Just that's the question.
Yeah. So okay, that's a really good question, and that's what I wanted like people to chime in on now on what kind of properties we want from the queue. And I would be talking more terms in terms of SQS only. So I think Naga already mentioned that SQS guarantee, like once it will be delivered in the message, at least once in the queue. So once it is in the queue, what things can happen now? I think DP was mentioning, or someone was mentioning, like how long it should be in the queue. So if I have not picked up this message, how long it can be in the queue? What is the retention period? Generally, SQs gives like up to 14 days. If you have not read that message in 14 days, it is gone. So that is the configurable thing. Then what next? So this can go up to 14 days. And the other thing is what kind of retry mechanism it can give. So basically, I think somebody just mentioned, if the message is read, but something gone bad and could not acknowledge, would the message should be deleted or still keep in the queue? So basically what SQS gives you that as the infrastructure, that if you read the message and you didn't acknowledge that I have successfully read that, it will keep that in the queue to the number of times you define. I think by default it is 3, but you can make it 100,000, whatever number you want. It will keep in the queue and keep on incrementing the count. Okay, this message has read once, twice, thrice, and once it reaches the threshold, it will remove from the queue.
Yeah, and one practice here is normally if something fails, if you are not able to process that message successfully, there is another concept called dead letter queue, which where you place these messages, and there is some other mechanism which we need to find out for dead letter to process.
So in the typical scenario, so retry mechanism, then the third one is visibility timeout. We'll come to that in a second. But are you clear with this? How long in retry mechanism?
Yeah, I have one question. I'm new to this SQS. Do we have something called as a back-off algorithm kind of stuff in SQS? Like my first message failed, and due to some reason, and second time I want to try after 1 minute, and again it failed. The third time I won't be trying it after 1 minute. I would exponentially increase based on my back-off algorithm.
Yes,
like 1, 3, 6, 9, and something like that.
Be based on this visibility timeout.
Okay.
So we'll come to that. But right now the message in the queue and different services are processing these messages. So do you think like the same message can be picked by 3 services?
I think yes, it could be.
So, I think there should be some method so that when there is a contention between multiple services, there should be lock or timeout or some sort of mechanism should be there.
So generally this visibility timeout helps. So generally we put like, okay, this is a property on again SQS. I can say like once the message is read, it will become invisible for 60 seconds. So what happens, like if this message is read by this instance, then that message will become invisible for next 60 seconds. So, and I'm assuming here like my service is efficient and it will able to process this message in 60 seconds. If it couldn't and doesn't acknowledge it back to the queue, then it will become again visible and then again can be picked by some other instance. And this time the retry count would be 2. And again, if this service couldn't process it, then it can pick by some other instance and the count will become 3. And then after that, once it reaches 3, it will be gone from the queue. And we can even, I think, tweak with this visibility timeout. I think Raghav was mentioning like a back-off algorithm that if this service picked and couldn't process for 60 seconds, when the next service will pick and again couldn't process, it can give a signal like, okay, this time the visibility increase it to like 5 minutes, 10 minutes. There could be some issue with the system. So then it will become invisible for that amount of time.
But how this is solving the problem? Like again, after 60 seconds, many people can, many instance can pick at the same time. Like
it is possible, but there would be so many. So there would be so many messages, and I think the possibility is really low. Like at same timing clock, both instances would pick up the same message.
But how it is different? Like it was at t equal to 0. There were many people who were eligible to pick it up.
Yes.
So in that only so suppose we guessed like only S1 picked at that time, then it went. So we are just minimizing in processing things to disappear. Like at the same time, many instances can go for that. We can have something like lock or something like that, that one service can only go at the time of picking the job. Like with disappearing, we are just minimizing the in-process things. Like if it is taking like 5 seconds, so S1 after S1 finishes and tells that it has done or not. So that's why that we are only minimizing what I feel with visibility, not the same time it can be picked by.
Same time, even I don't have a really clear answer on that, how that queue will avoid, like like say there's only one message queue and there are 10 instances. I think it has, but there would be still some difference, like how like 10 instances would be talking to the queue. There would be some clock system and how these all, and once has picked, it will become invisible for the others.
Yeah, once is picked is fine in visual, but same time they can be picked. Like,
anyone has a better answer?
Yeah.
You mean like the question on exponential backoff?
No. So question is, Naga, there is only one message in the queue and I have 3 instances and both are talking to the queue. How I will guarantee that only one will pick? It should, like all 3 should not able to pick at the same time.
So maybe like a distributed lock.
But we are not locking the message. The queue is handling that.
Yeah, the queuing mechanism normally.
Sorry. So that is my best guess.
I've worked on this, and what I understood is this problem will be handled by what is that message is there in that topic and which consumer is being subscribed to that topic.
So this is not a topic-based thing right now. This is not Kafka. This is basically a queue. Think in that way. This is one topic, and there are 3 consumers.
Yeah. So the consumer will, when it requests, will kind of put in the queue too, right? So let's say we have 3 instances. We have 3 consumers right now. The 3 of them come. Let's say suppose they come at the same time. So they put in the queue. So the first one, go and then pick up the message and set the visibility, right? So now the first one handled that. The subsequent one go in, then because the visibility, it equals 0. So, it's not there.
So we have a queue system similar to, not like SQS, but we have our own queue system. So what it does is, like, we have a status 0. Once a app, once a server is picked for processing, then the status will be changed to 1, and at the same time it sends a ACK from the server saying, okay, I picked it, and you change the status to 1, so that other servers won't pick it at the same time.
Basically, you are putting a lock, right? If 3 of them come at the same time, same nanosecond timing, then there will be still some locking thing. Okay, one process has picked, it is locked it. You make the status change, you release the lock because it is
But it's a race condition, right? Like it's a multi-threaded environment, right? So obviously one thread, it won't go to that lock.
Yeah, I would like to add something here. So we in one of my project, we had our own queue. So we have used a mutex lock over there. So if multiple consumers or multiple instances are trying to get a hold on or trying to put something or read something into the queue, so lock pretty much handles. So we have many services running on our device, and all of the services can try to read the messages or write the messages to the queue. So we make sure that if the same message ID is coming into picture, based on the lock, we handle that situation. So it's pretty long time ago. I think we handled using mutex lock.
So I think long story short, SQS would be doing this.
Yes, and as Somas or someone is saying that we were having a status for each message also. What is the current status of the message? That is a second level check. Even if at the same time, as you were saying, nanoseconds or something like a second request comes into picture, we make sure what is the status of a message, whether it is under processed, already processing or not. That is another guard condition we put inside our logic.
So yeah, so somebody asked that question, is that gave some more clarity. I know there would be really lot in kernel. And I think this is a similar situation in any distributed system where we are doing similar pattern.
But I think lock would like degrade the performance, right? Because everybody come at the same time and lock, and then only one of them enter the critical session, and then everybody have to wait, and then it do again and again.
Lock would be only the message. So what is my understanding? It will lock the message for a nanosecond, change its status to invisible, and release the lock. So after that, no other person can neither acquire a lock or not able to see the message. That's not my understanding.
Yeah, but at the same time, many others have to wait for that lock, right? I suppose they come and the one to acquire that lock.
Like I think this standard delivery is different. People can put lock on different messages. It's not supposed to be like first in, first out. So that's why that's why I think SQL is cheaper, like with standard delivery, because we are not saying like only the first message is processed for the first time. Then if the different consumers are coming, they can put read a message from the queue. So that's all I think I'm putting my assumption.
Yeah, just one thing I have to add. So you're saying that a lock is basically given to one consumer, and he observes it, and then he sends an acknowledgement, and then that message would be visible to other consumer to consume. Just one thing, let's say if I have multiple consumers that I want to somebody I think brought up about Kafka, right? That for one topic there can be multiple consumers that might be observing it, right? Mm-hmm. So is that a possibility over here that I can group my consumers together and that group can consume the message together as well? So is that a possibility? Can we form groups and something of that sort in this particular scenario as well, along with locking?
I don't know, but I think this would be like
you are talking about sub, right? Like that's a different scenario. I mean, like since the locking will be different in that case. So if you think about like the queue, it's about like only one needs to pick, right? That's why we have a single mutex lock. Either you get it or you don't get it. But in other scenario, which like sub, how threads work is basically it will be in the form of semaphore, if you know about like operating system concept. So semaphore is basically you just have a number of permits. So depending on the number of subscribers, you can just set it like I think there is a different way to handle the consumers of a topic versus a consumer of a queue. So
but in case of semaphore, there will be multiple subscriber will be processing the same message.
That's what we wanted, right?
Yes, that's what we wanted.
So,
yes.
but at the same, but at the same time, we want to make sure that the one message should be processed by one subscriber. Is not that the case?
No, but then we can have that sort of a functionality in the group itself, right? That group is considered successful if the entire consumer, everybody in those who are observing that group, everybody gets the one copy of the message itself. Then only we send an acknowledgement. We can have some sort of that mechanism, right?
So, yeah, I think let's discuss this probably when we go to the topic. So yeah.
This answers that thing which we discussed in the start. Why we keep sessions? Okay, so I will right now park this as a race condition for me. I am assuming I have like 100K messages coming, and very less possibility that one. Okay, let's say if once all three services pick that message, still it won't change anything because we always talk about stateless systems. Okay, so but I will not again go to stateless systems. But I'm considering that if I have designed my system in a way, if all three services pick the same message, still it should not make the make different decisions if one has picked it up. So that is how I have done my underneath layers. And now right now coming back to this, as soon as this one will pick this message, it will make this invisible. If couldn't acknowledge, it will again come back. If this couldn't process that message, again it will come back to the queue. Might be it will pick up this guy, it will again come back to the queue. So 3 of them couldn't process it. What should I do now? Like discard that message, throw away, what should I do?
Is it something like mechanism dead letter queue in the SQS?
Yes. So generally there is a concept of dead letter queues. So as if after 3 retries or n retries it couldn't process, we generally send it to another queue and call is dead letter queue. Generally, I have seen the cadence that if the dead letter queue is growing, it will alert the on call, and the on call will investigate that why it is growing, or it should be self-healing. Like there could be a bug in the service or something is going wrong, and if this dead letter starts growing, then somebody has to go and see what's going on.
You mean this should put some notification to the developer? I mean, dead letter queue should put some notification to the developer that it's getting, okay.
So this is like what we discussed last time: alarms, monitoring, thresholds, pager duty.
Yeah.
Some triggering mechanism that, okay, this dead letter is growing, somebody should go and see this thing. Does that...
Sorry, these queues, what happens if the server holding the queue goes down? Like these queues have like a database behind them, or is it in memory? What's...
So right now I'm assuming that I'm using queue as my software as a service. I have offloaded this to either Amazon or Azure. So they would take care of things behind the scene. I only care about the guarantee that my message should be there. So as an application developer right now, I'm not so much bothered like how Amazon would handle it.
But to answer your question, if the server is not finished yet in processing the message, it didn't send the acknowledgement back to the queue. And then that's why the message will go back to the queue. Usually that is the case.
Mm-hmm.
So basically it's not in memory. Basically there's a backing.
So whenever application retrieve a message from the queue will actually wait for acknowledgement if the message has been done processed. After a certain amount of timeout, if the queue didn't get the acknowledgement from the application server, then it will put the message back to the queue.
The service, you mean SQS service?
The SQS, yeah, the queue service, yeah.
So how that is working, I don't know internally where they keep it in the memory or in the database, how they manage it. But but right now, if I'm in the interview, I won't go into the details. I will say, okay, I would like to stick around. Like I have a queue. These all properties queue is exposing to me. I will play around that for my use. Like I will add some retry mechanism. I will add some visibility timeouts. And use these properties to develop my application. And so why I'm discussing about these properties, because now I'm scaling my services. What will happen when I add more instances and other things? These properties would help me at that point of time.
I think interview-wise, I think the more question that is fair to be asked is what is the trade-off between SQS and SNS or Kafka? I think that is a fair question in the interview. But if they ask to, what is the data structure behind the queue? I think that is going to be a different scope. I think that will be the interview question itself. Like, how can we design a queuing system? Yeah. So I would be prepared how to answer what is the trade-off between SQS and SNS and Kafka.
Mm-hmm.
That makes sense. Thanks.
Okay, cool. So right now, another thing which I have seen with the queue is if same message is interested in order service and same message is interested, let's say some other service which is let's say search or something. So I have seen like generally in my experience, we don't reuse the same queue for different services. So this service would have its own queue, and the same message would go there. Because if you've seen these properties, this will make it invisible, but and as soon as it will be invisible, search service should not be able to pick it up. So search service should have its own queue with the same message. Does that make sense?
Yep.
And how this message can go to different queues, there this guy comes into help, like a SNS topic. It's a if so, think in that way. I'm pushing it to a topic. Whoever subscribe to that topic will get that message. So my service does not have to care which queue it should be sending it to. It will be sending it to topic, and whoever is interested will get that message. This is again a standard way of doing broadcasting messages. Does that make sense? Why I put that topic?
Yeah, just one thing I want to ask: how do you maintain the ordering of the message in this case? Let's say I am sending different messages through the queue, and you said that initially ordering is not maintained in SQS, right?
Yes.
So how do you ensure that, like, let's say my service wants to get messages in order because it has to do processing in an order. It has a priority order by the time, like it should maintain its FIFO properties, what I'm trying to understand. So how do you ensure that?
So SQS gives these two things, either FIFO or out of order. So if the order is prioritized, then I think we need to go with the FIFO. If the order doesn't matter and your application can handle the order itself, then it can go out of delivery.
Okay, cool.
But are we clear with this topic thing? Why we are broadcasting and why every service should have its own queue if they're interested in the same message?
So Aseem, did you mean like if multiple services need that message, we need to put that message in SMS topic?
I will send it to a topic. Topic will broadcast to whoever is subscribed to it. So if a new service is interested, it will put its queue and subscribe to that topic. So this will send to all the subscribers.
So you're saying that here the individual queue is a subscriber for the topic?
Yes.
Okay.
So the service does not care who is interested. Service will send it to topic. Whoever is interested will subscribe to a topic and say, okay, I'm interested, give it to me.
So here the queue is for each service, right?
Yes, because if you like we discussed that what are the properties of queue, like retry mechanism. If multiple services are reading the same queue and one acknowledging it, it is gone from the queue. Other service will not get it.
Okay. Other way, I was thinking, Aseem, like let's say if all the services read the message also, if somehow one service is processed also, for that service there is some caching mechanism and it says message is already been processed. So it doesn't need to process it again. Because in this case, what is happening, we are duplicating the message across the queues.
Yes. Yes, that could be a different design decision, like you mentioned, handling at our side. So basically, it could be a different way of doing things. I've seen some places where, I didn't get exactly your thing. You are telling like one service will pick and cache it on their side.
Yeah, means what I meant to say is, like, let's say 3 services want that message. So I will put that message in one queue, and every means it's a broadcaster to every service. So if they want to handle that message, they will handle it in their own, like the message type or whatever the message would be. Means I'm not.
Yeah, so I think one of the things that you're touching on is that when the service is broadcasted and it's in the queues of different microservices, the idea is that each of those microservices will be actually having their own functionality. So if one microservice picked a service from the queue, from its own queue, and processed it, that doesn't mean that the other service doesn't need to process it, right? It's serving its own functionality. So it needs that service for its own use. They're not like, they're kind of mutually exclusive in some way. That's what my understanding is, but Aseem, correct me if I'm
Yes, so
That's what I meant to.
That's what they are different in their functionality, and there would be extra logic on the service to decide whether to acknowledge or not acknowledge. And so I think I didn't get the exact question what you were asking.
So Aseem, what I meant to say is, let's say every message would be having one type. Now, let's say this message is broadcasted to N services. Now,
when you say N services, it won't get broadcast. It would like how the service will get that message. Service has to listen somewhere.
Yeah, just like the way you mentioned, like this topic means whoever is subscribing to this topic, that guy will get that message.
So I have not seen right now how a service can subscribe to a topic.
Yeah, Aseem, can you please tell me, is it that the case that only one queue can, so one service only listens to one queue, and then from one topic there can be multiple queues? Is that the case over here?
Yes.
With one service there is only one queue.
Yes, that's what I'm proposing, my design, but there could be always alternate designs. That's what we are discussing. So right now the design we are discussing is that, let me make it clear.
Yeah, so here what Aseem is actually trying to handle the scenario. So where we have a message and we want two separate service, and both actually want to process the same message, but in a different way.
So
and we may have a number of instances for one type of service to process the message.
Yes. So there could be multiple instances of this service. There could be multiple.
But in that scenario, you can just put it in the queue of that particular service, right? And then there can be a load balancer, and then it can distribute.
Yeah, so that's what that's what he's explaining here, that the topic is actually, you can say, it's some sort of a intermediate service which take the input from your producer and put that in an individual queue.
So
one question. One thing that it looks like people already know, which I don't know, so I want to make it explicit. So each queue which is dedicated to serving a service, who creates that? Is that the owner service creates the queue and registers that with the topic?
Yes. Yes. So if some new service like catalog is interested in this, what it will do, it will introduce its queue, introduce its service, and then also subscribe to the topic. And later, if some new service is interested, it will also put its new queue and subscribe to the topic. Or there could be other ways to subscribe also, I think like SMS, like Amazon SNS gives different ways of subscriptions, email, SMS, queuing, other ways. But it has to be some process. There should be some way of communicating to subscriber. And somebody was mentioned like directly catalog service or some service subscribe to a topic, which I don't know. I have not done that in my experience. Like how a service can directly subscribe to a topic, because services instances keep on changing. They can go away. There would be a lot of things. I have seen like putting a queue to a topic, and then and people can just communicate to the queue would be one thing which I've seen in the past.
Yeah, there could be a number of ways to solve that problem. So the ultimate goal here is that we want to process the same message by two different services.
Yes. And there are different ways.
That is the problem we are trying to solve here.
Yeah, there are different other ways which I think can be done here. Like somebody mentioned in the start, Kafka. I would not go there. But there are different design decisions we can take, or like somebody mentioned, there should be only one queue, different services talking to them, and maintain this order themselves. But this was something I have seen in the past, so I thought to share with you, like where to introduce a topic. If somebody talks about a topic, why the topic is helpful.
Just a simple idea. So as Naga told that we were having some type of counting semaphore in the sense of if there are multiple consumers. So instead of having a queue, instead of having a separate queue for each and every services, So we can, I mean, just an alternative solution that we can also have a queue with a counting semaphore that this much as messages consumed by this much of services.
So
Can we do something like that also?
Then it's too much for the queue to remember which. So queue will become stateful. It has to remember which service came and listen the message. There could be n services. It has to remember, okay, these n services are talking to me.
Yeah, so semaphore may not solve the problem, but yes, if you want to go with a single queue, so you can put some sort of a flag, or you can keep the information who actually already processed this message. So I don't need to serve this message to that service. Now,
Yeah, I mean, there should be a different mechanism to handle all those things. Okay.
Then the queue will become a kind of a pub sub thing.
Pub sub, yeah, exactly.
Which actually Kafka solves that problem.
Yeah.
So Kafka, what we are discussing is doing the same thing. You have one topic and multiple subscribers, and then it maintains who is talking, who has read that message, who didn't read that message.
Yeah, exactly.
Okay, so so this was, I was thinking to bring a point like where you can you can broadcast, different services can listen it, and then they handle it. And I think that's what, like, I was trying to give the overview. You can go and read what different properties of simple queue service that could be helpful in the interview to tell, okay, there could be a retry mechanism, there would be like a guide letter queues and other things. So
I have a question. Does the queue guarantee the deliver the message first? I mean, if I send, I'm as a user, send message 1 and message 2 to the queue. So does the queue guarantee to deliver the message 1 to the consumer first and then deliver message 2?
No,
it will be put to the queue. You will get confirmation if the message is already in the queue, but it's going to depend on how the consumer consume it.
Yeah, but would that the consumer see the message 1 first and then see the message 2?
Yeah, the order.
The order is not guaranteed.
The order is guaranteed. Depends on whether you configure it or not. But you can have that feature enabled on SQS Amazon to guarantee the order.
Yeah, it is like FIFO or out of deliveries, like standard. If you have if you put FIFO, it is a guaranteed order, but it is costly.
Yeah, I want to know why it costs, if you don't mind, because I was thinking maybe, yeah, why costly?
I can explain maybe a little bit. So in distributed systems, the biggest problem is like ensuring things are coming in order, especially like when there is a chance of concurrent, right? So the moment you are trying to make system distributed, the common strategy is to partition and try to put messages in each of those partition, like based on some hashing, right? But then the moment you split those messages into different partitions, then like you don't know whether the message in partition 1 came first with the message in partition 2. So this kind of challenges come up when you make when you're designing distributed system, right? So that's the reason even Kafka ensures only order with respect to partition, but does not ensure the total order across all the partition. So that's the biggest problem. Like if you want to ensure order, like that's the biggest pain point of distributed systems. You have to give up your performance and the scalability aspect if you have to ensure this order. So that's the reason like FIFO is not as scalable as the other standard queue. And it's since it costs to maintain the order, even Amazon, I think they charge.
Might be, yeah. So what I felt even the same way, they have to maintain the order. A lot of things, these locking things would be different when basically they have to then think a lot about the locks also, because then there is a situation, and when if I have 10 consumers, all of them will try to get the first message in the queue. So that's what I feel, that why it is more costly. I didn't read much about that, but that is my assumption.
Okay, so in that case, if we make the order undeterministic, then probably the consumer can maintain the order.
Consumer, so we have written a consumer in a way that the order doesn't matter. So consumer can process the message in a way that it does not care which order it came, and it will be able to handle it, or it will do some kind of check, like if some message which it has consumed. So every message would have a timestamp. So let's say we get a message 1, and then message 2 for same user, or something like same primary key. It could make a check like, okay, if it has already processed message, let's say process message 2 first, because it's out of delivery, and it will make a check, okay, I have already processed which has a higher timestamp, and then M1 is coming which has a lower timestamp, then don't use it. You already have a latest timestamp which you have.
Yeah, so I think we have worked in market. I've worked in market data. So there, what we do is basically, when we receive we receive sequence numbers from the source, and what we do is, let's say we would maintain 2 buffers. So let's say one buffer. If something comes out of sequence, we'll put that into another buffer, and if we keep queuing it until we receive a message that is out of order, and that is a bound threshold. It's not like indeterministically we keep it. That we would keep it within the bound threshold, and then once we receive the sequence number which is in order, we just stack it up and put it behind the queue, and then we just push it to the end source. But then again, there is a limit on the amount of the time we can do that and stuff like that.
But that would assume that 2 messages arrive at the same instance, right? If 2 messages arrive different instant, then it doesn't work.
It does, because what we are saying is we are basically dealing with the sequence number, right? So whatever sequence number, let's say 2 comes in first, and then we wait for 3 and 4, and let's say 5 comes in, we will just keep it another queue, and later on when the other, let's say 3 and 4 packets come in, we will first push in 3 and 4, and then I'll push in 4, 5. So that's how I'll do it.
But is that the queue per instance? So you have queue on this instance 1 is different than queue from instance 2.
I don't think I understood your question. So basically, I'm just talking about one process. So we are maintaining this at the service level, the service which is consuming the data.
So Leon, this could be a really subjective question based on what kind of service we are dealing with, and that's a design decision. If it is out of delivery, then the consumer has to find out some way to figure it out whether this message is the old message or the new message, or what is the sequence. It could be like in what I think Debaklin was.
Dev Kalyan.
Dev Kalyan, sorry.
Yeah.
Dev Kalyan is telling that if all the message sequence matters 2, 3, 4, 5, then we have to wait till all of them arrives. Otherwise, if for me, I always want the latest sequence like 5, and if I've processed it, and if 2, 3, 4 comes, I will discard it.
Yes, but I'm saying that become the bottleneck, because if that are 1, 2, 3, 4 after you arrive at the same instance of the consumer.
Yeah, so consumers, then let's say like consumer, then like again we have to go really deep in the discussion that how then probably they will have some caching layer in between, distributed cache, where they will maintain, okay, which message if a sequence 5 already processed and somebody is trying to process sequence 3, then that will say, okay, my sibling consumer already processed it. Then
we drop it. We drop it actually.
We have to add.
Yeah.
There could be a database, there could be a cache, there could be a file system. But what I'm trying to say is that again is subjective to things which you are building. And if we have taken a design decision of out of delivery, then the consumers have to coordinate to make a decision that whether I have to process this message or not.
Yeah. Okay.
Like again, it's so as a developer, that's what we are doing, like writing code to make sure that what design we are following. And this entire thing can be replaced with the streaming systems like Kafka or Kinesis, where we don't need multiple queues. The system itself can handle multiple consumers. If you want, I can briefly talk about that. Otherwise, I think we are good with this discussion.
Can you please tell us about the streaming thing once? Knows about Kafka, but about streaming once.
Like Kafka, I think is a streaming kind of a technology where you stream things. That's what my.
How does streaming work? That does it also has like topics and partitions, and then there are multiple multiple consumers consuming from those partitions. Does streaming work in a similar fashion?
So now this is my current system. Let's assume I have to take this system to what they say, something like streaming architecture like Kafka. So everything, these all things will go away. And there would be this Kafka thing. There would be a topic, which was like my queue. There could be multiple topics, which will act as a queue. Here it will assign to topic 1 and multiple consumers, consumer 1, 2, 3, and they again can have their multiple instances, C3, C2, and C1 hash. So what generally, how this thing works is, this guy maintains what all the, so every consumer will have a consumer ID. They will share across, and then it will remember like, for if there is a message here, it will remember like whether this message has gone to that consumer or not. It will maintain something like a log or zookeeper, that how many consumers I have and which consumer has read till which message. It could be like offset, like they have. So that is mostly like a FIFO thing. Till this offset, these consumers has read that message.
Okay.
And it will also know like how many instances are there. If there are 5 instances, it knows like, okay, 5 people are trying to read me. And every topic then can have multiple partitions. Partition 1, partition 2, partition 3. This could be like a sharding thing, where different messages can go into different buckets. That's what is. And then how it works is, if there are 10 instances of consumers or for the same topic, it will try to map 1-to-1 mapping with 3 of them. So these are like, think in that way, these are same service. If there is a 4th one, it won't allow it. So basically it will allow only one consumer to read, consumer to read a partition. And it also do like a heartbeat check, whether this consumer is actually up or not. If that is not up, it will remove that and put C4 here and assign it to C4.
Yeah. I think that's how even Kafka works, right?
This is Kafka explaining.
That's what I was actually. Yeah, so that's what I was actually asking. So, but my question was, how is the streaming which you pointed out is different from Kafka? That was the.
No. I mentioned streaming is Kafka.
Acha, okay. That's fine. I'm so sorry.
I think the important part.
Because there is Spark streaming also as well. I think I was reading somewhere there was something called a Spark streaming as well. Like, was just curious is that like Kafka only, or was that something else? Yeah, that was.
I've read it. It comes from Confluent.
Yes, Confluent maintains that of Apache.
The important part about using Q, I think in my experience, is how we can have some like helper application to see what is inside the queue, because it is always tricky. It is not easy to find out what are in the queue or looking for a search or something. I think in our experience, we we need to move it to like MongoDB to localDB to kind of be able to search what is in the queue. I think that is just a good side note. If we want to implement the queue system, we need to have like the helper to do some searching in the queue for troubleshooting purposes.
Yeah, so that is a good point. And I've seen like queues are for me are really lightweight. And doing with this Kafka thing, somebody has to manage this Kafka cluster, how this will work. And you see like, I have seen there are issues also where they claim a lot of things like offset and other things, but it can go wrong at any point of time. But it is maturing. I've used both Kafka and queues, but I think it again subject to a design discussion, whether you want to maintain the full-fledged Kafka cluster or not.
And I think at this point, none of the technology allow us to easily search what is inside the queue, right?
Or in the topic.
Or in the topic, yeah.
Yeah, that's hard also, right? Like searching
yeah.
queues are not, it doesn't store like a database, right? Like tables which have the indexes to speed up the search. There is no indexing concept.
So our workaround, usually we move it to a like local storage first, but still need to maintain the order, right? And then we do the search from there, but it is just a pain in the ass.
I'm curious, what kind of use case is it that, you need to search through the messages?
Yeah, so usually, let's say if it goes to the that letter queue, right? And then and then we have a customer who complains, hey, my order is not being processed. My order is in a stuck situation, right? I think if we don't log properly, then we need to try to see whether that unprocessed order is stuck in the queue, or is it processed already, or is it going to the dead letter? So that kind of use case often happens in our experience.
And I have seen with Kafka, this dead letter things is tricky. You have to do the dead letter yourself. Kafka won't give you a dead letter unless you put in a separate topic, which will act as a dead letter for you. But that won't come out of box with Kafka. You have to manage the dead letter yourself. But with queues, it comes out of box.
Yeah, I don't see the use case for searching in the queue. But we can look at like what end up in the queue or what exit the queue by looking at the log, right? Even if we say, okay, this message end up in this queue at this time because it enter the queue at this time in the log.
Yeah, assuming that you have like the very robust log, and oftentimes the queue, the producer and the consumer are different application, right, or different team, right? So if I'm just a consumer of the queue, I need to rely on my producer, who could be on a different team or different company, right, to have that robust logging. But if I don't have that capability, and that my customer is complaining why my order is not being processed yet, and then let's say you have 1 million items in the queue, you need to know, right, whether that item is in the queue, or it's already processed but we missed it for some reason.
Or producer never sent it.
Yeah. So I think that is a use case that we see a lot in our experience.
Like Indra mentioned, I don't have producer logs. So I don't know even ever producer has sent that message or not.
Correct.
This brings me to an interesting thought. Like, how is it that, let's say, somebody's pushing in messages at an extremely heavy rate into the queue. So like, you want to write to the disk. So how do you keep up with that? Because, someone's processing it at an equally quick rate, and somebody is pushing into the queue at an equally quick rate. And then you say that you want to search through the queue, and basically, you are basically saying that you are writing to MongoDB. So how do you cope up with such a situation?
Yeah, we usually ask the producer to send us the logs or proof, like, hey, can you please check whether you have sent it to the queue or not? I think that is more practical than, well, again, it depends on whether you have a good helper application to transfer to MongoDB and do the lookup. But if you don't, then you need to ask your producer to send us logs. Actually, that is the problem that we are working on like these past weeks. I need to chase the team who put the message in the queue to make sure that they have put it or not. And sometimes we catch that they drop it somewhere before they put it into the queue, but they drop it in their process, and then yeah.
Okay.
And
So,
yeah, I just wanted to add something. The Kafka normally stores the messages just like even the queues, like for 7 days or 14 days. I think 7 days by default. And though the consumers consume the message, it doesn't remove the message in Kafka. Only their offset will move forward. So
yeah,
that's the idea. And I think whatever the retention period, after that retention period, Kafka will automatically remove those messages. Until then, it will be there in Kafka.
So
Is it the Kafka
I
log?
think, yeah,
Is it the
Kafka,
Kafka log?
I didn't understand.
So is that Kafka log where they store the, I mean, type of thing, if type of backup data?
No, it's not backup. I mean, like I meant to say the Kafka topics will have the data for the number of days. You said the retention for like 7 days. If you said 7 days, your messages will keep playing. Whatever the producer writes into the topic, it will stay there for 7 days, whether you consume or not. So that's the idea. So even if you consume, your offset will keep moving as from consumer standpoint, but the messages are actually there in Kafka. If you ever want to go back and reprocess, you can reset your offset and start processing again.
But after that retention period, your message is gone.
Yeah, it's gone. Yeah.
And
So
then this
the
is
idea
important.
If you
important
want
to set an alert. Yeah, to set an alert if the partition is being consumed or not. If you see like the partition, Kafka partition is stale for a certain amount of time, then you need to alert your team the Kafka is not being consumed, and then because in 7 or 14 days depends on your configuration, but the message will be gone forever.
That would end up in the dead letter queue, right?
No,
No,
for
there
Kafka,
is no
it
dead
will be
letter
gone.
concept.
So, but I've seen like there is a new another discussion which people are saying like use Kafka as a database, store it forever, and then it will have all your history. But I have not explored myself.
Yeah, that's configurable actually. You can. It's not like 7 days is fixed. That's a default configuration. You can always change. Yeah.
Use Kafka as a database.
Yeah, but actually the lookup gets trickier because the topics are ever growing, and yeah. So I mean, like it can scale, but.
So another thing which I think I've used in the past with Kafka, what we call it the CDC, change data. What was that full form? I forget. Change data capture. So basically, Kafka is having your all changes incrementally in the sequence, and at any point I can go back and rebuild my system with that. But again, that is I'm just throwing some keywords. But I would not able to go in depth in that. But yes, high level, this is sorry, I couldn't get too much into Kafka things. I think for many people it would be like, oh, what's going on? What is Kafka now? We are talking about queues. Sorry for that, but I thought it could be interesting discussion if I just mentioned, and you can explore a little bit offline on that.
Aseem, I have a question because when we started this topic, back of my mind, I was correlating with some of the popular websites how the order management system works. So consider a case if any website which works in a country like India, like Flipkart, where OTP or second level of authentication at a payment gateway is must to have. So does asynchronous queue applies over there also or not? My first question. Because the moment you place an order, it goes to a payment gateway, Once you enter an OTP, as soon as you enter an OTP, we get a confirmation from the payment gateway and we say that, okay, order confirmed. Unlike if I place an order at Home Depot in West Side on a Home Depot where the OTP is not mandatory. So we get an confirmation mail, order placed, and a few minutes later we get another email, order confirmed. So seems to be when we get a second email, order confirmed, that time behind the scenes asynchronous queues play into picture, right? So if we go back to the first case where the Flipkart case, so can we apply there also?
Again, this OTP one-time password is, I think, from the merchant, like Visa, correct? So as soon as I have contacted Visa, so basically, let's say this is my queue and this is my order service. It picks up this message and it contacts Visa. And again, Visa has to acknowledge that message, it has whether it has been done or not. So I think so. This is the responsibility of the Visa to get the OTP. So as soon as my order service will call Visa, it will talk to consumer, and if the OTP response will come within time, it will acknowledge back. Otherwise, it will say no, this request could not be processed. Order service will put another thing in the queue that with the something like bad payment or something. Then another process will read that queue and send a message to the client. Okay, whatever information you gave or things you did, the payment didn't work out. Sorry, we couldn't process your order.
Right. So what was the reason most of the old website says that kindly do not refresh the page or something like that at a payment gateway level?
Oh, okay. So it depends if that is synchronous.
Can I assume that if I get a message on a website, kindly do not refresh a page at a payment level, so it means it is fully synchronous?
I think so. I think so. Yeah, I think I got your point. Mostly I've seen the sites in India, they kind of synchronous there. They want to immediately find out whether the payment works or not, unlikely in here in US, Canada, where they first, based on your credit card information, they assume like you are a authenticated user, you are not stealing somebody's credit card, and then they just charge it. So I think there it's more like a use case of synchronous payment verification. But still, once the payment is confirmed, most of the things I think work asynchronously, figuring out whether the inventory is there.
Yes, yes, that's true. After that, everything can work asynchronous way.
Yeah, I think that it again a design decision how you're building the application. If something has to be synchronous, it has to be synchronous. There is no other way.
Okay, thank you so much.
This was the starting discussion that we did. You remember?
Sorry?
I'm saying this was exactly the point that I was making initially. Like it's a bit different when it comes to India because we make the payment before and then we like do all the manifesting and everything in the background.
Yes. But here in US, it's different. It if the credit card number is good, the validity is good, and the CVV is good, it's just put in the queue.
Yes, yes.
Much about
yes. In West, I think 99% all the website works that way.
They don't care. Like they assume you are a good user.
Yeah, can we talk about how would we scale when synchronous, payment have to? We have to implement synchronous payment.
So I've seen. You can scale the max you can scale. At some point, you have to then deny like too many requests. I've seen in India, Flipkart, at some point, the peak, they will start dropping requests. They'll say, okay, we are overloaded. Please try after some time. That's what my assumption. Otherwise, again, if we are thinking about scaling, then every component which is involved with that should scale. It could be like the merchant. What all components? So here we are talking about this is order service. Immediately it should call this Visa. Visa will do other things, and after that it has to talk to some other component, it should happen. Then again, the scaling we already discussed, like every component has to scale either vertically or horizontally, wherever it is needed. If some component is not able to scale, then we have to send something like a bad request or error code back to the user.
But at what sense we say, you know, we don't want to horizontally scale, you know, more instances to handle it?
So I will say that generally every team knows when there could be a peak. If it is like a Prime Day sale, generally they try to maintain, they already scale that up either using the past data or decisions, and things can work. I don't have a proper answer to that because again, this is subjective to design what we are doing and the system we are building, how to scale which component when, and how much I want to invest in the scaling. Because the more hardware I'll add, the more cost I'm getting charged. I don't know if I've answered your question, but again, it is really subjective to the design, what we are doing. Or someone wants to chime in there. If nobody wants, then I think I'm pretty much done with this queues thing. Again, you can use this, like there is a concept called event-driven architecture, which works like this. One component talks to other component, sending a message that will read that message, acknowledge, and move forward. Like entire system is talking to each other using events.
So I want to know if the Kafka, all these message queues are for the inter-service communication, I mean inter-microservice communication, or the event that you're talking about that is used for the communicating.
When two components used to talk, they can put a message in a queue, other component will read it. It could be a microservice, it could be a standalone process. And again, it has to communicate, it will again put that message back into either Kafka or a queue. The other component will read and say, okay, that is done. So basically what we are discussing here is generally how the two components will this is component one, this is component two. It could be a microservice, it could be a standalone process. It will send a request, it will get a response. Now we have removed this synchronous thing. It will send a message, other guy will receive a message. It's same like if I have to give an analogy that somebody sent a message to you on a WhatsApp, you will read the message based on your availability. Once you read the message, you send another message to the sender back, okay, this thing needs to be done, or this is my response, and the other message will process whenever it can do that. Unlike I make a direct call to you and say, hey, response me immediately.
Yeah, okay, so it's like non-blocking thing.
Mm-hmm.
Yeah.
Just some analogy.
Just a simple question. So you told that most of the websites in the West, they work in the asynchronous manner.
No, I didn't mean that way.
No, it means just, I mean, most of the websites just work in the asynchronous manner. And in India, it happens like something, most of the websites are in synchronous manner. So in terms of the design, we should work in this in asynchronous manner, or we should put in synchronous manner. I mean,
see,
what should be there? What is the better approach?
So so there is no one right or wrong answer. Again, it depends on the requirements. So let's say you are building a tail site in India, and your merchant visa or somebody is telling, hey, you have to always do a synchronous payment validation because I have to check for a OTP. So this is your requirement. You can't go change that requirement from the visa. Like visa is telling, I can only tell on fly whether the payment can be possible or not. So I have to design in that way to accommodate my my sister services or some sister APIs. instead of if I'm here, if the service says, okay, you can send me a request, I can respond you later, and that is fine, then I can say like, okay, asynchronous can work here for me.
Okay, so it exactly depends on the use case.
Yes. See, how we build a system based on the requirements and the what I would say based on the capabilities of other systems I'm talking. For example, you're building a system which do authentication using Facebook. Now, what Facebook will provide, you have to go with that. If Facebook says, okay, I can do on fly, okay, that's good. If Facebook say I can't handle that load, it has to go through some other cycle of validation, and for that I need time. So you have to wait. So basically, that's why we say whenever we so generally, probably next week when we do a real example, we'll say, okay, these are my requirements. These are the components I want to talk. This component has this limitation. So based on that, now I have to take this design decision here, until the other component change itself.
Okay.
And that's why we never stop in one design. It's keep on evolving. You might have heard in your team setup, hey, the other team is coming with the V2 version. That time we'll handle this use case. So I think that's from my side. I think this went really, some things people might not able to correlate because we are talking things, queues, Kafka, and somebody has worked earlier could have a better understanding. But I thought this could be useful if you read a little bit more about it, and in a real system design interview, try to bring these components in, okay, based on the use case. And again, in any system design, we don't need to have 100% perfect. That's what I've seen. You have to take some decisions which seems reasonable at that point of time, and it doesn't work, which will change it.
So one thing, will the queues be a single point of failure if we are using a single queue?
Single queue for what? All consumers to one single queue?
Or maybe like you said, like we have a microservice, which is actually.
So basically, we were discussing like there would be multiple queues, and all the different services reading that queue. So if I'm building this queue system, then yes, if the design question is building this queue system, I have to think about single this failure thing. But I'm right now assuming that AWS is handling for that for me. It is guaranteeing me that availability will be 99%.
Okay.
So again, if I'm building this queue, I will tell like what is my availability, what is my consistency.
I think there are different levels of redundancy, right? Geographical, there would be like data center, geographical, and like different kind of redundancy techniques are there, right? So we could pick from like any of the ones, just that the price, the cost would be different, and like how much redundancy we want, right?
Yeah, so like one of my friend always say, like the more you put money, the more better sweetness you'll get out of it. So it's again the way how much you will put, the more you will put a cost and better things you'll start getting. But as a design thing, we have to see like in a design question that whether that I need right now or not, whether I need a multi-region or not, whether this much investment I need or not. Okay, I think that's all from my side. I will stop the recording and then we can keep on having the questions.